Hello online viewers, welcome to our lecture video. In this lecture video, we'll be solving the equation x cube minus x minus 1 equals to 0 using Newton Raphson method, and we'll find the roots of this equation correct to 4 decimal places, and we'll be solving this equation by setting function in our calculator to make our steps to make our process easier and quicker. I have already created a video on how we can solve the equation and find the roots using first method, false position method, and second method, whose link you can find in the description box below. So before jumping into the solution portion of this video, firstly I'd like to talk about Newton Raphson method. What is Newton Raphson method and how we can use it? So for our Newton Raphson method, our so let's say if we have our initial approximation a, then our initial approximation a, so here our a is our initial approximation, then our first approximation x is given as a minus fa divided by f prime a. So we have our function fx. So for this our root x is given as a minus fa divided by f prime a. We will be calculating f prime x, and we'll be setting a in fx and f prime a in f prime x, and then we'll simply find our first approximation x, and in the next step what we'll be simply doing is we'll set a equals to x. Then our second approximation x1 is given simply as x minus fx minus f prime x, and we'll be continuing this until and unless xn minus 1 is less than or equal to our tolerance e. So I'll be explaining this by solving our equation. So for our equation, what we'll be simply doing is, here we have fx equals to x cube minus x minus 1, and since we'll be needing the first derivative, we'll calculate our first derivative as f prime x equal to 3x square minus 1. Derivative of x cube is 3x square, and derivative of x is 1, while the derivative of 1 is 0. So we simply get f prime x equals to 3x square minus 1. Then we'll be calculating our tolerance. Our tolerance is 4 decimal places. Our tolerance is 4 decimal places. This is given in our question. We have correct to 4 decimal places, so our tolerance is simply equal to 4 decimal. Our tolerance is simply equal to 4 decimal places. Next we'll have our error e. So let me write it down over here. Error e equals to 1 by 2 into 10 to the power minus n, which is equal to 1 by 2 into 10 to the power minus our n is equal to 4. So we'll simply write over here 4, which is equal to 0.0005. So we get our error e. So this simply means we need to find our xn minus 1 less than or equal to 0.0005. So this is our meaning. So this is our meaning of our error e. Next we have our first approximation. We let a equals to 1. So our initial approximation a equals to 1. Let a equals to 1 such that fa equals to f1 equals to, so we simply put the value of 1 in our equation fx. So we get this as 1 cube minus 1 minus 1, which is equal to minus 1, and we have our f prime a, which is equal to f dash 1, which is we put our value of 1 in our first derivative f dash x. So we get this as 3 into 1 square minus 1, which is equal to 3 minus 1, which is simply equal to 2. Then our first approximation, then we get our first approximation as, first approximation is simply x equals to a minus fa minus f prime a. So using our formula from Newton Raphson's method, we have our first approximation as x equals to a minus fa divided by f prime a. So next we write here our value of a is 1, our initial approximation is 1, and we have fa equals to minus 1 divided by f prime a is 2. So this is equal to 1 plus 1 by 2. So we get this as 1.5. So we get our first approximation x as 1.5. So now our further calculation will be in tabular form. So we have further calculations. So we can write this as further calculations are are tabulated below. Further calculations are tabulated below. So what we need to do next is we need to create some columns. So our first column is n, our second column is going to be for a, and our third column is going to be for x. So we'll be requiring these three columns. We won't require any column for fx. So now I have 1. So firstly I have my value of a as 1. My initial approximation is 1, and I got my x as 1.5. So next step I'll be replacing a by x. So I get as 1.5, and I need to calculate the value of x. So now what we'll be doing next is we'll be setting function in our calculator to make our process easier. So firstly what you need to do in calculator is you need to click on shift and mode, and go to number 6. You can see fix over here. Click on fix, and it asks you to fix from 0 to 9, and we need to fix up to 4 decimal places. So this is what our question demands us. So click on 4. Next what you need to do is we need to set a function to calculate our x. So we have our x given as x equals to a minus f a divided by f prime a. So we have our x as x cube minus x minus 1, and we have our f prime a as 3x square minus 1. So we simply need to set this in our calculator by using certain variable. I'm going to use variable c equals to a minus our f a simply becomes a cube minus a minus 1, and f prime a becomes 3a square minus 1. So I need to set this in my calculator. So you can use any variable, or you can use x as well. You can use a b c d. You have enough variables. You can use any variables from a b c d e f x y m. You can choose any variables. Right now I am choosing c, so I'm going to click on alpha, and I'm going to click over here c. So as you can see here, alpha, and click on c. Over here you can find a b c over here. So click on alpha and c. Next you need to click on equals to. Alpha equals to, click on equals to over here. Click on alpha and then click on calculate. Don't click on the equals to over here. You need to click on calculate over here. Next you need a. We need to represent a. So I'm going to click a minus, I'm going to use this equation. Now I need a cube minus a minus 1. So a cube minus a cube minus a minus 1 divided by 3a. 3 alpha, click on over here, a square minus 1. Next what you need to do is you need to click over calculate. Do not click on equals to over here. You will be getting syntax error. So click on calculate. So it asks me the value of a. So my first value of a is 1. So let me click on 1. After clicking on 1, I need to click on equals to. Then I'll get my value of c, which is actually my value of x, which is 1.5. Then I click on equals to one more time. It again asks me the value of a. So I'm going to enter my value. So my next value of a is 1.5. So let me put on 1.5. Click on equals to. Then I get my value of x as 1.3478. So let me simply write this down over here. 1.3478. Now for my third approximation, I simply need to put 1.3478 in the place of a. 1.3478. So I go back to my calculator, click on equals to. Now instead now I put 1.3478 as the value of a. Click on equals to, and then I get my value of x as 1.3252. So as you can see here, the difference between x3 minus x2 is not less than or equal to 0.005. It is much more higher than that. So I go in my fourth approximation. I put 1.3252 in the place of a. Go back to my, so after putting the value of 1.3252 in my calculator, I get my value of x as 1.3247. So now for my fifth approximation, I simply put 1.3247 in a, and I click on equals to, and I put 1.3247 and click on equals to, and then I get my value of x as 1.3247. So as you can see here, my x5 and x4 are same. So here x5 minus x4 equals to 1.3247 minus 1.3247. So simply equals to 0.0000. This is less than or equal to 0.0005. Therefore my required root is x equals to 1.3247. So in this way using Newton Raphson method, we have solved the equation x cube minus x minus 1 equals to 0, and we have find the root of this equation correct to 4 decimal places. So if you like the video, do subscribe the channel, like the video, and if you have any queries, you can comment down below. Thank you.